This video assumes that your software installation is complete, and it's now time to set up and better understand how Milestone handles video storage and retention. To do that, we need to access the Milestone Management Client. You can download it to your local workstation from the management server machine by opening a web browser and connecting to the IP address of the management server, followed by a /installation/admin. You'll need to log in with either a valid Windows domain credential or the machine's Windows username and password to access this page. Milestone is integrated with Windows accounts and Active Directory automatically. As such, there's not a default password, but instead, to start out, you can use the credentials of a computer running the Milestone Management Server, or, if applicable, an admin account on your domain. If you're using the desktop of the management server machine, you can also log in with that local user without needing a password. So let's start out by setting up our first storage container where the video will be saved. Remember, it's highly suggested to use one or more dedicated video storage drives or drive arrays that are not the same drive or a partition of the drive your computer operating system is on. Click on the recording server on which you want to set up storage. If you're running Essential Plus or Express Plus, you'll only have a single recording server listed here, but our advanced products may have many different recording servers listed, each of which may be in a different physical location and each with its own video storage drives. Once your recording server is selected, choose the Storage tab. You'll see that you've got a default storage configuration already set up. Click on that and double-click the storage container in the window below. Now you can see where the storage container is located, what the video retention time is for that container, and how large it's allowed to become. You can set up multiple different storage configurations, each with different retention times, on one or more drives. Depending on your storage level, you may have a box for signing, which is used to prove the exported video hasn't been tampered with while it was on the server. So you should always make sure this option is checked if it's available. And again, depending on your software level, you may have the option to encrypt the video storage. However, due to increased CPU requirements to encrypt the video recordings, this should only be enabled if there's a strong need, such as medical privacy requirements, or if the video recordings saved in that storage container are of a particularly high security nature. This first example shows us that video placed in the storage container will be retained for 30 days and will not be archiving to another location. This means that the video will only go here, and that the system will automatically check every few hours for video that exceeds the retention time, deleting any excess video footage as needed. The storage size is seen as a hard limit, meaning in this example, even though our drive may offer over a terabyte of free space, the amount of video stored in this container will not exceed 500 gigabytes. So if desired, you could make another storage container on the same drive, perhaps with a 300 gigabyte limit and a 15-day retention time. So some of your cameras could optionally store video here instead, retaining the footage for 15 days. In the event a storage container fills before the retention time is reached, video will be deleted on a first-in, first-out basis. It's best to avoid this situation, however, because it increases disk activity by making the system delete video more frequently. Instead, it's better practice to ensure that you have extra available space in your storage drive that's never quite filled. Setting up storage in this way is the simplest and least expensive method, but comes at one risk. Before rebooting a machine containing a recording server, it's important to always stop the recording server service. The best method for doing this is simply going to the recording server tray icon, right-clicking, and choosing Stop Recording Server Service. Wait for the icon to turn red. Only then is it safe to reboot the machine. In the event the system restarts without first properly shutting down the recording server, the video storage drive may need to be re-indexed, resulting in the system remaining offline while that process completes. Systems with longer retention times and larger numbers of cameras will often want to archive video, which is the process of bringing video in briefly to typically smaller, faster drives, and then regularly moving that footage out to long-term storage locations, typically composed of larger, slower, less expensive drives. We'll make two examples to illustrate the archiving behavior. In our first example, we've got our initial storage container defined. This resides on drives that are fast enough to handle all the cameras on the server detecting motion and needing to store video simultaneously. In this example, we have our retention time set to 24 hours, and we've made sure that we have far more than enough storage space than we anticipate needing. Next, we'll set up another storage stage by clicking the Add Archive button. Here we choose the location where the new storage container will be created. It's important that this new location be on a completely different drive or drive array than where our first live storage container resides. We'll set our retention time to be the grand total cumulative amount of time that we want to save our video, and make sure that we have sufficient space allocated to the storage container. Lastly, we'll leave the archive time set to the default of midnight. It's important to understand that the archive time, or the frequency at which we archive, is a completely different function than the video retention time. When archiving, the system behaves differently than what we described before. Unless the live storage drive fills up prematurely and is running out of space, video is only moved to the archive location based on the archive schedule that we've defined, which, in this case, is daily at midnight. This means that on day 1 at midnight, nothing will happen. This is because there's not yet any video on the storage drive that is older than 24 hours. On midnight the following day, the archive will occur, and the system will detect that there is 23 hours, 59 minutes, and 59 seconds of video older than 24 hours, and will then move that older video to the archive location, leaving behind the most recent 24 hours. Archiving does not empty the live storage location, but is instead copying off video that exceeds the specified retention time. In our next example, we'll modify our archive container and set the archive frequency to be hourly instead. This means that every hour the system will check to see if there is video exceeding the retention time for the first storage location. In this case, at midnight on day 1, again, nothing will happen. This is because we still don't have video exceeding 24 hours. However, at 1 a.m., when the archive occurs again, it will detect video, approximately 1 hour's worth, that exceeds the 24-hour retention time, and it will copy that hour over to the archive location, leaving behind our specified 24 hours of video. Again, when archiving, it's important that the location you're copying the video to is completely independent from the live storage drive. This is because video is always copied, not moved. If you're trying to archive to a partition of the same drive, or another drive letter residing on the same overall RAID array, you'll often run into disk throughput problems due to the system trying to copy many gigabytes of video to the same set of drive platters that the system's using for incoming video. You always want to read from one drive or set of drives and write to another, such that the data is flowing in one direction. We do support archiving to shared network storage, but this is often problematic as it is less efficient and requires careful management of the service permissions running the Milestone software to make sure that it has read and write access to the shared drives. Storage locations allowing block-level control that show up as attached storage, even if that storage is iSCSI or Fiber Channel over Ethernet, is much preferred for its greater efficiency and easier setup. Lastly, our corporate and expert users will see an option for Reduce Frame Rate when setting up archive locations. This is a feature called grooming. When dealing with H.264 video, if this box is checked, regardless of the numeric value, the video will be reduced to keyframes only, thus lowering the frame rate and reducing the size of the archive. Industry average is 1 keyframe per second, but it varies based on how the camera is configured. And that covers the basics of Milestone video storage. In the next video, we'll add cameras, configure their settings, and set up motion detection.